Recognize washer type. The first thing we need to do is recognize the washer type we have. I'll be tearing down a Maytag washer, but other brands and styles may be of the same type. To get on the same type for sure, let's look at a couple of items. If you look at these pictures, they look different. One impeller is taller, but if you pull the fabric softener dispenser off of the right one and look down towards the bottom, you'll see that they both have their impellers to spin shaft bolts near the bottom. This indicates that your gear case in both has a short shaft and probably have the same gear case. To confirm, look under the washer. As we look underneath, most likely it looks like this. What is called is a gear case with all the attachments, the motor, capacitor, etc. If you see the same thing under the washer that you have, we have a match. With that said, now we're ready to see what actual parts could be part of an unbalanced spin cycle. Okay, item number one is probably the biggest cause of an unbalanced spin cycle: the gear case assembly. If you look at the little black arrow, the top teeth of the spindle shaft gets bad from rust. The red arrow is the spin shaft which gets loose. Mostly gets loose from the third item indicated by the blue arrow, the bearing and the tub seal. They go bad by water seeping through the tub seal and rusting out the top bearing. All of these contribute to more give between parts. The second item is an inner tub to spin shaft coupling. The spin shaft is the outside shaft that the red arrow is pointing to. The constant close imbalance causes the screws and the coupling itself to wear to extremes. As space opens up between spin shaft and coupling, moisture causes rust buildup. As space opens up between spin shaft and coupling, moisture causes rust buildup around the shaft. The third item is the one most YouTube videos tell you is the actual cause for the unbalanced problem, but the suspension rods are the last resort put in to dampen the bumping of the unbalance. Now, I will not just order these without doing a complete inspection first, but I would always replace the suspension rods if replacing the other items we have discussed. If all the other items are in good order, new suspension rods would be a good conclusion. It's best to get a good idea about the total damage and the costs related before purchasing parts. Let's start the inspection and see where we're at. While we have the unit laying down where we can see underneath it, check on the belt shroud or belt shield and see if there's an oily residue. This one is really heavy with oil, but even a light coating of oil will be a sign of a bad gear case. You can count on over $200 for that item to begin with. Let's look at some other problems while we have got it turned over. If you take the belt shield off and look closer, you may find that there's a white powdery substance at and around the openings and holes associated with the gear case. This stain can also be found on other items attached to the gear case. This is an indicator that the top seal between the tub and the gear case is leaking water. With the leaking seal, the top bearing lubricant will be washed out and rust will begin to form. If water stains were found, let's confirm if the bearing is noisy. Set up the washer, put the drain hose in the drain pipe, and plug the washer into the electric socket. Turn the washer on the cycle drain and spin. If any noise is present, the tub bearing is bad. If there is no noise to be heard, the gear case will still need to be pulled out and the seal replaced. The top bearing cannot be replaced, so noisy spin means gear case replacement. All the rusty and washed out parts are going to contribute to an unbalanced spin cycle. Now, turn everything off, lift the washer lid, and see if the inner tub can wiggle back and forth inside the outer tub. If it doesn't, the inner tub, the spin shaft is good. If there's even a little bit of movement, then most likely the coupling is bad. The coupling is found underneath the impeller, but I wouldn't go any farther unless you do have some play. The video shows the movement found when the coupling is bad. At this stage, the impeller has to be removed. To take the impeller off, you need to take a 7/16 bolt out from under the little cap, and then you take each edge of the impeller and you wiggle it up to bring it off. If you have a good clean shaft, there's no problem removing the impeller. In most cases, I could not get it up because it was bad underneath. Most of the ones that I've worked on, if the washer has this play in the inner tub, I couldn't pull the impeller off without having to use a little bit stronger way. I had to cut it off using an angle grinder, chisel, and hammer. You have to make sure you clean everything off the shaft to impeller coupling. You wind up having to grind on that and taking a chisel and a hammer, knocking it all off. The tub to spin shaft can now be seen. Wiggle the inner tub and watch the looseness in the coupling. Most likely it can be seen clearly now. Again, the coupling causes an unbalanced spin cycle. The impeller will cost about another $60 to $80. From this picture, it confirms a bad tub seal and bearing, teeth eat up with rust, and an inner seal bad. Now the last item to talk about are the suspension rods. If you've went through everything else and there's no oil on the belt shield, no water spots on gear case, no noise in the spin cycle, no play on the inner tub, you are in great shape. Replace the suspension rods. You will find plenty of videos showing how to open the washer top and how to replace the rods. If the gear case, the coupling, and now the impeller needs to be replaced because we had to break it off, cost to fix now exceeds over $300 altogether, not including your labor. You may want to consider that before you start putting a lot of money into your washing machine. I only have one more section to go. This is where I give you my thoughts and my reasoning why so many of the parts go bad. But before we start, if you like the way I presented information, please take time to hit the like button below and send comments. These will help me decide on making other videos. Let's look at the engineering specs of the washing machine when it is new. Looking at the balance line running across, no matter how careful you distribute your clothes around the washing machine tub, the spin cycle will start unbalanced. As the washer starts the spin cycle, the inner tub is going to wobble as it catches up speed, and with the help of the dampening rings built into the inner tub, the wobbling becomes less and less. If you could see inside the lid while the spin cycle starts, the inner tub and outer tub will look like they're wobbling together, but in actuality, the two tubs are not connected and there is some time between the inner tub and outer tub impacts. Let's look at a couple examples to help understand what is going on. First up, we have the dominoes all setting up, and as the finger pushes the first one, they all fall down, one at a time. And they finally hit the last one, knocking it over. Even though the first one started the action, it did not impact the last domino directly. This action is known as the domino effect. The second example is called the Newton effect. When you take the first ball, consider it the unbalanced inner tub, and you drop it, it hits the second ball, the tub coupling, which hits the third ball, the spin shaft, which in turn hits the fourth ball, the top gear case bearing. In the duration, no movement is seen, but each one has been impacted individually, and when it gets to the last ball, which we would say is the outer tub or drum, it reacts by slinging itself up. You can see that each one of the balls or parts has been impacted and causes wear. Keeping in mind the two examples, let's look at the washing machine again as the spin cycle starts. Inner tub starts bouncing, it moves outward, impacts the inner tub to spin shaft coupling. Next, the coupling in turn impacts the spin shaft. The spin shaft impacts the top bearing. Then the top bearing impacts the gear case housing, which is connected by long screws to the outer tub or drum. All this looks like it happens instantly, but in fact, it's the domino effect. As each part is impacted over and over again, each part begins to wear a little more and a little more, have more spacing between each part. This wear and spacing causes the outer tub wobble or bumping to be amplified. Them poor old suspension rods try their best to dampen the effect caused by the poor engineering. I hope this was informative. Until next time, this is Royce L. Sanders and his bucket of tools signing off.